Hello guys. Okay, still on our biomolecules, we are going deeply into something lovely now as we delve into what is called your monosaccharides. I'm going to be showing you every singular lovely things that you should know about monosaccharides. We're going to look at their structures, look into a whole lot of lovely things. If you are not yet subscribed to this channel, step 1, get subscribed. Click on the subscription button and then turn on the notification bell so that immediately we are dropping classes, you are the first to follow us. If you're just meeting me for the first time, of course, I am Sir Peter and this class is proudly sponsored by LearnLift. Let's go together, guys, as we proceed and learn a whole lot of lovely stuff. Now, this is it. Under your monosaccharides, what you must understand here is this very simple and direct. Monosaccharides are the simplest group of carbohydrates. So, the simplest of all carbohydrates is called monosaccharides. Now, and we call your monosaccharide simple sugar. Why do we call monosaccharide simple sugar? Of course, these guys are called simple sugar because they cannot be further hydrolyzed. In other words, if I mix it with water, of course, hydrolysis is going to react with water. If I react monosaccharide with water, it cannot break down to give me another different compound again. Are you getting me? Or another form of, well, which other type of sugar is it going to give? It's not possible. That's why I say that they are called simple sugar. They are the simplest form of sugar because they cannot be further hydrolyzed to give you other sugars that you need. Now, this is it very quickly. This structure we see here, of course, is a monosaccharide. Are you getting me now? If this guy reacts with water, it cannot give me something simpler than this anymore. No, it's not possible. Now, this is it. You must understand this with me very quickly that there are properties of monosaccharides that you should know. How many properties? We are going to dwell on 4 of them. Number 1 property is called colorless. So your monosaccharides are colorless. Number 2 is called crystalline solids. They are crystalline solids. And then number 3, they are soluble in water. Wow, very soluble. And then number 4, they are insoluble in non-polar solvents. Let's look at all of them one after the other. Let's begin with the first property, which is called colorless. By colorless, what are we referring to? You must understand this is very fast that monosaccharides are typically colorless substances. Oh yes. Do they have their own color? Are they colored or they are colorless? They are colorless. Why are they colorless? If you say they are colorless, what does it mean? It means that they do not have any inherent color when in their pure form. Now, impurities can impact color on them, but in their pure form, they don't have any inherent or inbuilt color. Are you getting me now? The reason for this is that this property is due to the lack of chromophores. Oh yes, so from the name chromophores, so that it has to do with color. And these chromophores, they are the group of atoms that are responsible for absorbing specific wavelength of light and giving substances their color. In other words, if you lack chromophore, you are going to lack your true color. Simple as that. So your monosaccharides, they have chromophore, they lack chromophore, they lack chromophore. Because they lack chromophore, they lack color, hence they are colorless. Second property of your monosaccharide is the crystalline solids. So are they solids? Yes, but what type of solids are they? Crystalline. This is it quickly. Know that monosaccharides are usually found in the form of crystalline solids. By crystalline means they have shape, they have morphology. This means that their molecules are arranged in an orderly repeating pattern or format, meaning that they have pattern in which they are repeating themselves or they have pattern in which they are organized or arranged. And this is what gives them a well-defined structure. See, one sweet thing about your monosaccharides is this. We can actually say that they have order, they have shape, they have pattern. Because of that, the crystalline structures contribute to their physical properties. So the physical properties of monosaccharides is because of their crystalline structures. And this makes them distinct from every other liquids or amorphous solids. Now, when they say amorphous solids actually they lack form, they lack shape. While your crystalline solids, they have form or they have shape. So for monosaccharides, are they crystalline or they are amorphous? Of course, they are crystalline because they are shape and what? Form. Another characteristic is called your solubility in water. Your monosaccharides, are they soluble in water or they are insoluble in water? Of course, they are very, very soluble in water. Why is it so? Take note that they are not just very soluble, they are highly soluble in water. Wow! So this property is due to the fact that they have what is called your hydrophilic end. The hydrophilic end here, or the hydrophilic nature from the name hydro means water, and then philic there is phileo. It means loving. So your monosaccharides, are they water loving or they are water hating? They are water loving. That means they are hydrophilic and not hydrophobic. Are you getting me now? Why is it so? It's because they have what is called your hydroxyl group. The hydroxyl group that you see in them, that OH that is linking to them, the OH group that is present in monosaccharides, have the ability to interact with hydrogen bond. When they interact with hydrogen bond, they will give birth to water. And that is why they easily dissolve in water. Of course, you know your monosaccharides, they already have we said that they have polyhydroxy group. So that polyhydroxy group in them, OH group, can react with hydrogen and then they will give birth to what? Water. Another thing is this solubility is essential for their role in biological processes, because there is a lot of biological processes that they carry out. So their solubility in water make it very easy, and then it allows for the transport and utilization of this sugar in living organisms. The brain needs sugar. Oh yes. So, but how will the sugar go? It needs to be in the dissolved format. So it needs water to dissolve it. Now, this is it quickly. By us saying that your monosaccharides cannot undergo hydrolysis does not mean they cannot dissolve in water. Let me explain. By hydrolysis means that they will react with water to now form something that is entirely different from what they already are. It's not possible. Now, what happens is this: in your monosaccharides, they are soluble in water. Of course, take your sugar, pour your sugar inside water. Will it dissolve in water? Oh yes, it will dissolve in water, meaning it is soluble in water. If it dissolves in water, doesn't mean that it is still not sugar. It is sugar. It has only dissolved in water, not that entirely new compound is formed. Are you getting me now? That's that. Another thing you must notice is they are insoluble in non-polar solvents. This is it. What is called your polar solvent and your non-polar solvent. Of course, water is a good example of your polar solvent. Kerosene is non-polar solvent. Your monosaccharides, are they soluble in polar solvent or non-polar solvent? Of course, they are soluble in polar solvents and they are insoluble in non-polar solvents. Why is it so for their insolubility? You must note this, that monosaccharides are generally, all of them, they are insoluble or non-soluble in non-polar solvents. A good example of the non-polar solvents are the benzene, the kerosene, the toluene, etc. Now, this is because non-polar solvents like your kerosene, they do not have the ability to form hydrogen bond with monosaccharides. Now, this is it here. Your water is H2O, right? If water dissociates, what will you give? H plus plus your OH minus. Are you seeing it? This H plus that we have here, because your monosaccharides, they are polyhydroxyl, this H plus have the ability to react with the what? OH group. Are you getting me now? It is not so. When we come to your non-polar solvent, they cannot react with non-polar solvent because non-polar solvent cannot donate hydrogen bond that polar solvent will on a normal day donate to them. Since monosaccharides are polar molecules themselves, why they dissolve in water is because monosaccharides are polar molecules or they are polar solutes, and polar solutes will only dissolve in polar solvent water. Non-polar solutes will dissolve in non-polar solvents. So as a result of this now, what happened is this: your monosaccharides generally, they will have preference for water, not kerosene. Why would they not want to react with kerosene? Monosaccharides are polar solvents, right? Oh yes, polar solvents will naturally react with your polar solutes, and that's water. Non-polar solvents will react with non-polar solutes. Are you getting me now? So as a result of this, your monosaccharide do not really mix well with non-polar solvents, which have different types of molecular interaction. So the interaction of your non-polar solvents, they are different from the type of interaction that monosaccharides will generally want to find themselves. Are you getting me? Don't forget these 4 amazing properties of monosaccharides. They are very, very important and essential. Now, let me show you something. 3 things that you should note very quickly. Number 1, let me start. The first thing is this: the backbone of monosaccharide molecules are carbon chains. So you can't have monosaccharide molecules if there are no carbon chains. That's why we said that the backbone of monosaccharide molecules, they are nothing but carbon chains. And these carbon chains, they form the main structure of these molecules. You can see very quickly here that in this structure, you can see your carbon, your carbon, your carbon, your carbon, your carbon, your carbon. In fact, what's the backbone of all organic compounds? It is all carbon, definitely. Another thing is this: this backbone is unbranched. This is it. organic compounds could either be branched or unbranched. It is not so for monosaccharides. No, monosaccharides, they respect themselves. They are mainly what? Unbranched, meaning it does not have any side chain or branches that are extending from it. No, monosaccharides are straight. If we are going in this straight format of it, as we proceed, I'm going to show you a whole lot on that is very quickly. But note this as the second thing to note very quickly, that the carbon atom in the backbone, they are connected to each other by what type of bond? Single bond. You can't go and see your carbon to carbon double bond in your monosaccharide. Now, how is this carbon linking to this other carbon? Of course, single bond. Yes, your single bond. How is this carbon linking to another carbon? Single bond, carbon to carbon, single bond. So they are single bond, which means that carbon atom is bounded to the neighboring carbon atom with a what? A single bond. Another thing is this. So as a result of that single bond, it will create what is called linear carbon chain. So what type of carbon chain do we have in monosaccharides? They are called your linear carbon chains. Very lovely. Now, the third thing I want you to note very quickly and hold tight is this. Bear with me very quickly. In the open chain form of monosaccharides, the whole of these two structures you are seeing here, they are open chain format of it. One of the carbon atom in the backbone is double bonded to an oxygen atom. This is it very quickly. You can see that out of these three carbons, here's your 1, here's your 2, here's your 3. Carbon number 2 here is double bonded. It has double bond to your oxygen atom. And then this carbon number 1 here has double bond to what? Oxygen atom. As a result of that, what happens? It forms what is called a carbonyl group. Of course, your carbonyl group, they are carbon linking to double bond to oxygen, and then just like this. So it now depends whether you decide to say, okay, let me say carbon linking to double bond to O like this and then like this. It's now your preference to say, okay, you here have hydrogen, and here let it be R, or let it be R, let it be R. It's now what we determine whether this guy will be alkyl or aldehyde, and then this guy will now be what? Alkanone, or your what? Your ketone. But carbon is double bounded to what? Oxygen, to form the carbonyl group that we have in them. Another lovely thing is this carbon atom is often referred or regarded to as the carbonyl carbon. So when I say carbonyl carbon all through the course of this lecture, don't forget this, that your carbonyl carbon are the carbons that carry the double bond linking to the what? Oxygen. Another beautiful thing is this, the carbonyl group consists of carbon atom bonded to an oxygen atom through a double bond. We've established that carbon is linking to oxygen with what type of bond? Double bond. Simple as that. After you get this quickly, you should note this with me very fast, that there's what is called the classification of monosaccharides. Oh yes, how do we classify monosaccharides? Not carbohydrates in general, no, only monosaccharides. How do you classify them? Monosaccharides are classified into two main categories. Now, what are the two main things that you look at to classify them? Number one is called depending on the functional group that they contain. So you can look at the functional group and then you can classify or categorize them, and then you can also base that on the number of carbon atoms they contain. So the classification of your monosaccharides is based on two categories. What's number one? Depending on the functional group they contain. And number two is based on the carbon atom that they contain. Let's look at the first, depending on the what? Functional group. Don't forget this quickly, that we have said that functional group can be defined as an atom, a group of atom and ion, a bond, an ion, a molecule or a bond that distinguishes the members of a particular homologous series from all others in terms of their preparation and its physicochemical what? Properties. Hooray. Okay, let's go, guys. Depending on the functional group that they contain, how do we classify them? Now, follow me very quickly. You should know this, that on this, we classify them into two groups. Either they are aldose or ketose. Now, you should know that there's what is called your aldose, or your ketose. Your aldose, of course, if you add S here, it becomes aldosis, and then S here is become ketosis. Now, which one is your aldosis? Which one is your ketosis? Aldoses are the ones that contain the aldehydes or the alkanals. Ketosis contains alkanones or the ketones. Now, look at this. As a result of this, a monosaccharide with a carbonyl group at the end of carbon chain. Now, where is the carbonyl group in this first compound here? The carbonyl group is at the end of it. A monosaccharide with a carbonyl group at the end of the carbon chain, what is it called? It is called an aldehyde group. So this carbohydrate that we have here, it is an aldehyde group. And because it is an aldehyde, it is referred to as an aldose. Just look at the end, you will know where each and every one of them belong. The carbonyl group in this first one is at the where? At the end. So what do we call it? Aldose directly. Now, if you come down to this second one, you can see that it's a different thing. The carbonyl group is at the middle, right? Carbon to double bond to oxygen. Where is it? Middle. Since it is at the middle, what do you call it? It's very simple. If the carbonyl group is at any other position other than the end, like the middle, it is called what? A ketose. So because it contains the ketone group, so what do we call that monosaccharide? It's called a ketose. So this monosaccharide here is ketose. This monosaccharide here is what? Aldose. So these are the two ways you classify them depending on the functional group that they contain. The next very quickly is this. Based on the number of carbon atoms that they contain, okay, how do I classify them on the number of carbon atoms? Now, this is it very quickly. This is it. You must understand that monosaccharides with 3 carbon atoms, the ones that have your 3 carbon atoms, they have a name. They are called the triose, trioses. So when I say triose, what's your tri? From the name tri, it has to do with 3 carbon. Os, they're talking about sugar. So 3 carbon sugar is called your what? Your triose. Now your 4 carbon sugar is called your what? Your tetrose. Tetrose is 4 carbon sugar. Pentose, what will it be? 5 carbon sugar. Hexose, 6 carbon sugar. Heptose, what are heptoses there? They are the 7 carbon sugar. Now this is it. Your monosaccharide, they range from 3 to 7. That's all. As we proceed, please take note of every single one of them. Monosaccharide is from carbon 3 to what? To carbon 7. That's the range of your monosaccharides. So your trioses, your tetroses, your pentoses, your hexoses, and your heptoses. These are the classification based on the number of carbon atoms that they contain. Now that you get that quickly, I want to draw your attention to something very lovely. That monosaccharides have a general molecular formula of what's the molecular formula? It's very simple, of course. It is your CnH2O in brackets your N. If you open this up, what is it going to give you still? It's going to give you your CnH2NON. So it is still the same thing that you have there. Are you getting me now? Another thing is this: the most abundant monosaccharide in nature is the one that contains 6 carbon sugar. That's the most abundant, and that's called the D-glucose. Please don't forget, what's the most abundant monosaccharide? It is called the D-glucose. And these D-glucose are also called your dextrose. So when you hear dextrose sugar, what is it? Your D-glucose. Now, which one is the D-glucose, sir? This is your D-glucose quickly. Now, in this D-glucose, see, look at it now. Let me show you 2 things here quickly. Okay. Let me draw your attention to something. Why do we call it D-glucose? It's either I call it D-glucose or I can call it L. There is D-glucose, there is L-glucose. But the most abundant monosaccharide is not L-glucose. No, it is D-glucose. Now, why is it so? It's so because, okay, there is a way you name your carbohydrates. As we proceed, I'm going to show you all of these things. But please, take note of the second to last carbon. This is the second to the last. This is the last carbon. This is the second to last carbon. Please, on the second to the last carbon, check the position of the OH. Is the OH to the right or to the left? OH is to the right. Anytime OH is to the right, what is it? It is dextro. Now, anytime the OH, if the OH is not here and the OH is now at this other location, what do we call it? Of course, it will no longer be D-glucose. It will be called L-glucose. 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 The same way we have dextrocardia, rotation of the heart to the where? Dextro to the right is dextro. Are you getting it now? Anytime you have rotation to the right, it is dextro. Rotation to the left, levo. Are you getting me now? So if the OH is at this location, what will it be called? L-glucose. But if OH is here, what will it be called? D-glucose. So in naming your carbohydrates, I've just given you one expo. Check the second to last carbon and check where the OH is. Of course, here is your right and here is your what? Left. You get the answer very quickly. And another thing again, I want you to note very quickly about your glucose. How do you know that, sir, this is glucose? Another thing about your glucose is this. The third carbon, this is carbon 1, this is carbon 2, this is carbon 3. Please, the third carbon, the OH of the third carbon is usually to the left. Don't forget. So this is the structure that we have for your what? Your glucose entirely. Are you getting me? Try and draw this down and rehearse it effectively well as you progress. Are you with me? So if you understand this quickly, take note of this very quickly, that the simplest member of monosaccharide, that's a name, the simplest monosaccharide are the 3 carbon trioses. Of course, if you have 3 carbon, you are tri. Are you getting me now? Sugar, O's. So trioses are the 3 carbon monosaccharides. Now, a good example is called your glyceraldehyde. Glyceraldehyde is an aldotriose. Now, listen. Get the name first so that I will show you the structure. And number 2 is called your dihydroxyl acetone. Now, this is it. Hold on, calm down. We have your glyceraldehydes and we have your dihydroxyl acetone. Let this name permeate in you. It's very simple. Your glyceraldehyde and your dihydroxyl acetone. This is it quickly. Your glyceraldehyde that you can see is an aldotriose. So how do we know it's an aldotriose? The reason why it's an aldo, let's start it gently first. Is it an aldo? Let's check it out. Of course, this C to double bond to O, where is it? At the end, that makes it an aldo. Is it a triose? Oh yes, it is a triose because this is carbon 1, this is carbon 2, this is your what? Your carbon 3. So we call your glyceraldehyde an aldotriose. Don't forget that. Another is your dihydroxyl acetone. This is your dihydroxyl acetone. It is a ketotriose. Why do we know it's a keto? Of course, it contains your ketone. This is the ketone that we have there because the carbonyl group there is at the middle. And is it a triose? Yes, it's a triose. This is 1, this is 2, and then this is 3. Of course, that means apart from your aldotriose, we also have aldotetrose, aldopentose. We also have your ketopentose, ketotetrose, and so on and so forth. And you get so you are seeing the way those guys are named. The simplest monosaccharide. Please, how many carbon do they contain? 3 carbon. And we say they are the 3 carbon trioses. A good example is your glyceraldehyde. And glyceraldehyde is an aldotriose. And number 2 is your dihydroxyl acetone, which is a ketotriose. Don't play. It's very, very important. Now that you get this, in our next class, guys, I'm going to be showing you the examples of all the monosaccharides, one after the other, from carbon 3 all the way to carbon 7. I'm going to be drawing all their structures. Very, very important. See, if you're not yet subscribed to this channel, ensure you do that very, very quickly. And if you have not yet downloaded the LearnLiftApp, go and download the LearnLiftApp, where you have access to all the PDFs directly. You have access to a lot, thousands of questions that you can play with. You go over them again and again and again and again and ensure that you are well cooked and well prepared, guys. And you have all the videos in well organized and arranged format just for you. Enjoy yourself, guys. See you in the next class. Examples of monosaccharide. Take care.
Hello, guys. The class you just finished watching was brought to you by the LearnLiftApp. If you enjoy the content, don't forget to subscribe to the channel and turn on the notification bells so that when beautiful and educative videos drop, you would get notified.